Maintaining grid stability in the face of skyrocketing demands requires more than just infrastructure updates. It's going to take a fundamental shift in how we manage energy at the customer edge. The future of the grid isn't about traditional one way communication. It's about embedding core intelligence into utility customers' homes to enable real time, two-way interaction. Doing so requires innovation that can support this kind of change. And that's exactly what Sense is looking to do as part of their efforts to transform the relationship between people, homes, and the electric grid. Sense partners with meter manufacturers to offer utility software that helps them meet their electrification goals. But what does all of that mean on a practical level? And how can utilities leverage this platform for demand side management at scale? So to answer those questions and more, we're joined by Mike Phillips. He's the co-founder and CEO of Sense. Mike, really appreciate you taking the time.
Great to be here. Thank you.
So, I referenced your efforts to transform relationships between people and the grid in my intro, but from your perspective, what does that transformation really mean or entail?
Yeah, so actually our backgrounds came out of the consumer-facing technology world and the mobile phone world. So we were previously writing applications on smartphones for the early days of voice assistants on mobile phones again. And when we started Sense, we also had this view that if we could know in detail what happens in homes and could engage consumers around that, we could help consumers better manage energy in their home. And the first thing we realized is, well, to do that in any good way, you needed a real-time experience for consumers, and quickly found out we could not do that with the existing smart meter infrastructure.
And so, this transformation, it's about understanding on both sides though, because it's about enabling that better customer understanding, but then also on the utility side to know what they can look for or expect.
Yeah, I mentioned smart meters, and the reason those are so important is they're at the intersection between homes and buildings and the grid. And there's so much that happens in that interaction. Like, the grid has been designed to operate based on whatever the consumers might do. So basically, the supply has to follow whatever the load is. But with now more and more EVs, more and more heat pumps, more and more renewables on the grid, the better matching supply and demand on the grid is just becoming increasingly important. And the meter is a place that can do that because it's at the intersection.
Well, and it's about, as you said, like that expectation was associated with what was built in historically, but that's you can't rely on history in that same way based on, all those innovations you just mentioned.
Yeah, and to reference back to my lead-in, like I say, we had previously been writing software for smartphones, heard about smart meters, thought we could just write for software for smart meters. Quickly found out that the previous generation of smart meters, we'll talk about the next generation in a minute, but the previous generation of smart meters were just data collection devices. They collected 15-minute interval data of your energy use, send it to the utility, usually hours later, who could then make it available to applications. So as you can see from that, it's impossible to have any kind of real-time experience based on data from hours or days ago. And so that was the problem that we set out to solve.
Yeah, no, we got to get into the specifics of AMI 2.0, but before we get there, when it comes to how you're able to offer utilities a solution that helps with those electrification goals, is the biggest challenge around that about how they're approaching those goals or about what it means for them to set? Like, what is the headspace that you often deal with those kind of electrification goals and how you can best support meeting or maybe even establishing them?
Look, I do think that there's well understood dynamics these days, that the energy transition like entails like electrifying more as many things as we can, like this is heat pumps, EVs, and so on. So we need to electrify more of the overall loads and then decarbonize the electric grid. It's been kind of one of the goals of the energy transition. And but then then it gets tricky how you do that, right? Because if you just do it using the old way of making sure that supply can exactly match demand, no matter what the demand is, it gets really expensive. You have to build out all the infrastructure to handle the kind of planned worst hour of the year. And the thinking is, and I think everyone's on board with this, that if we had better flexibility of the end uses, uh, then the grid could be built out not just for the worst hour of the year, but could start to have a real back and forth between what happens in homes and buildings and what happens in the grid to better manage energy and reduce the need for massive infrastructure changes.
So we touched on the changes in expectation on both sides, both what the customers can do within their homes and then what utilities can look for. Like, is there a bigger challenge on either side in terms of getting either party to kind of look at what they're doing, but then make a connections? Like, where do you see the biggest kind of rub?
Well, look, on the consumer side, so there's only a couple things we really need consumers to do from an energy perspective. One is be more efficient where they can. Being efficient is still the lowest hanging of low hanging fruit out there. To find places where homes are wasting energy and solve those problems. And look, most homes have a couple things where if the consumer knew about it, they could easily fix it, whether that's making a behavioral change or swapping out some things in the home. Most homes have some real opportunities there. So that's number one. But number two, and this is becoming increasingly important, is provide flexibility when energy gets used. And by that, I don't mean the consumer having to watch the timing and only run their dishwasher at night or something like that. Recognize that there's a few things in your home that are major consumers of energy where you don't really care the timing. You don't care when your car gets charged as long as it goes far enough tomorrow. You don't care when your hot water actually, when the energy is used to heat your hot water, as long as your hot water is ready. So those are the ones that are great candidates for automation. So, software running in the meter in our case, software running in the meter should talk to the EV charger, talk to the hot water heater. By talk to, I mean through software interfaces, and have these things run at a time that is better for the grid, but doesn't interrupt the life of the consumer.
Yeah, and that's some of that touches on AMI, which let's get into it. So, can you outline the core difference between AMI 1.0 and AMI 2.0, and then specifically what unique capabilities Sense's software provides to unlock the value of AMI 2.0?
Yeah, yeah. So, and there are a few different definitions floating around out there, but let me tell you what we mean by it. So, the first generation of AMI meters were basically used, as I mentioned, data collection devices. They collect data at 15-minute intervals. So this is how much power you use over the last 15 minutes. They send it to the utility over a fairly slow network that the utility gets it hours later. Um, and we recognize to provide kind of more value for the consumers and to have a real-time experience. First of all, we had to up the data rates a lot. We are now have software that's running on the latest generation meters that are sampling power at 15,000 times a second. So if you do the math, that's 50 million times more data than before. And what can you do with 50 million times more data? We can see in detail activity. We can know when the microwave just turned on or when the dryer is done just from the detailed energy signatures. This is called load disaggregation. The technology's been around for a while, but it hasn't been able to be real time until we had this really high resolution data. The other thing we do with the high resolution data is we can see the grid from the edge. We can see faults and failures in the grid in this really high resolution power data. Things that happen in the grid show up there. So that's one thing we need in meters, so much higher resolution data. Now, we can't send 50 million times more data over the network. So that means you have to be able to process it locally. So that means the meters also need local processing. So software running on the meter versus just receiving the the data over the network. And then finally, we needed better networking. If you want a real-time experience, you need a real-time network. So the latest meters have high resolution data. They have plenty of local computation on them that we can run software, and they can connect up to the consumer Wi-Fi that provides these kind of real-time experiences and lets the meter do things like have software interfaces to the EV charger or the hot water heater and stuff like that.
When you touched on how there's some different definitions out there, and from your experience, are those different definitions based on maybe where a utility is at with their infrastructure or around the technology, that how the technology has changed or what they're using? Like what are some of the biggest factors in those differences, and what does it mean to get everybody on the same page or as best we can?
Look, it's really driven by the use cases. So I think it's now becoming pretty clear that what I just described, this kind of 50 million times more data, ability to run applications and having better networking, that kind of establishes the core of what is needed in next generation meters. And again, it's not because of the technical specs, it's because with those technical specs, we can do both these real-time consumer experiences and see the grid operating in real time from the edge. And frankly, the consumer parts are where there's a lot of value to be unlocked over time, but it's also the grid parts that are now driving a lot of utility decisions because resilience, fault detection, outage detection, and even wildfire risk detection are just becoming an increasingly important part of utilities' decision making as they're going forward with new meters.
So we already touched on the evolution of AMI 1.0 to 2.0, but how do you see this? Does this evolution have a connection to the smartphone transformation?
Yeah, I mean, given that we came out of that background, we we pushed for a similar notion to what happened in smartphones. Like if you look at your phone and ask like, how does something like Google Maps work with real-time traffic showing you where things are happening? It has access to the right data, so real-time GPS data in that case. The application, maybe people don't know this, but big chunk of the software for Google Maps is actually running on the phone. Some runs in the cloud also, but it's a mixed environment. And there's a network that now supports that. And what I just described on the phone case is what matches what we need now in this AMI 2.0, where we have, again, access to the right data, ability to run software at the edge or in the meter itself, and having better networking were the three things that made smartphones really take off, and what was not happening in the previous generation of the smart meters and is happening now.
Well, I mean, just so much of it connects to just the dynamic nature of 2.0, and that's just, I mean, to me, as you talk through that, that's just very different and just enables a lot of different things.
Yeah, look, and I think we've all gotten used to, I keep going on about this real-time experience. We've gotten used to that throughout our lives, right? You can open your smartphone app and see what your bank balance is right now, but you couldn't see your energy use. And and the other reason real time is so important is like consumers want to be able to make changes in their home. And if they can't see it happening, like they're looking at the app, they make a change in their home. If it doesn't happen at the same time, they can't associate what they're doing with their home with what they're seeing in the app. So having an app that says how power was used in your home yesterday just doesn't help you attach what was happening in your home to what you see in the app. So that is why we keep going on about this need for real-time experiences.
And you touched on this a little bit with that concept of when the hot water heater is actually heating the water, but can your platform facilitate automated or customer prompt and load reduction during peak events? And how does it integrate with or provide data to existing demand response management systems?
Yeah, so these are absolutely the things that we are doing now. And just to be clear, what I'm describing in these AMI 2.0 meters is just beginning to roll out now. We've had a lot of experience with this on the consumer side through a consumer retrofit device. So it's a little hardware device that goes in the home that was used and is used as kind of the proving ground for this kind of capabilities. Thinking of it as simulating what an AMI 2.0 meter does. So we've had those in market for a while and used them for some studies around demand flexibility, load shipping, and so on. But the meter version of it is just rolling out now. And as they roll out, absolutely using the meter as the ability to both see the load on the grid and control what's happening in homes becomes super compelling because the part that is really important is as it rolls out in meters, it will be in every home. So the distribution utility, the utility will have this kind of capability in every single home on their network, obviously subject to consumer opt-in and privacy stuff, but the core technology is available in every home.
Nice. And is that through an API, or what does it look like to access that raw data or to enable that integration, as you said? I mean, depending on the circumstance.
Yeah, so these kind of core capabilities is able to run on every single meter. Now, the consumer experience needs consumers to opt into that, right? Because these are just like on your phone, you opt into using applications on your phone. So consumers opt in to use applications, and then any kind of data sharing would be through permissions from the consumer. So it's not just suddenly the utility has access to all the details of what happens in the homes. That would cross a privacy boundary. But the utility would start to have access to all the stuff that is happening on the grid, seeing like things like knowing that a transformer is overloaded because of the total power draw of the houses connected to it, those are the sorts of things utilities will have right out of the gate. And then the ability to like mitigate that by saying, well, there's 3 EVs charging and we can ask them to delay by an hour to avoid overloading the transformer. That would happen through consumers opting in for allowing some degree of control in their homes.
Well, I mean, it speaks to a consumer customer education piece of this that is going to be a very important part of any change or update or upgrade. We can talk technology all day long, but if that consumer customer understanding isn't there, it's only going to go so far, which isn't very far.
Yeah, yeah.
What are there any specific opportunities for utilities that you're hoping to open up or showcase in bigger ways as these rollouts happen?
Yes, absolutely. I mean, utilities are rolling these out now, starting with kind of the consumer experience, again, for efficiency, load flexibility, and helping consumers with electrifying their homes. We can find the homes that are great candidates for heat pumps or smart EV chargers and so on. So that's kind of on the consumer side. We're doing a bunch of pilots now with utilities for things like vegetation management, dynamic load control, or knowing the kind of the load on a transformer and things like this, and even assessing fire risk. So we're working with some of the West Coast utilities to say, well, does data from the meter give you visibility into anything related to fire risk in the grid? And the answer is yes, it does, and that's then being combined with other data sources to help reduce fire risk.
Nice. And now that probably connects to some larger trends that are happening that you're looking forward to seeing take shape in the wider industry. But I mean, anything else that's top of mind for you in the short term or 2026?
Yeah, look, I mean, the important thing is that, look, I didn't mention this before, but we're not expecting any utilities to rip out existing meters and put in these AMI 2.0 meters just because of this. But as utilities are making meter decisions anyway for their next generation meters, it's really important that they are paying attention to these new capabilities so that they are now future-proof for the next 15, 20 years. Because, I mean, one thing we didn't mention, but it's an important point, is in the past, meters did what they would do. And this is true of most utility infrastructure. It had one purpose, and that was its purpose for the next 15 years. There's a lot that's going to be changing over the next 15 years. If meters are now thought of as a platform that can run software, that software can be upgraded over time. All the kind of use cases, we can start with a certain starting point, but these use cases and these software can evolve to match the needs of the utilities over the next 10 or 15 years. So that upgradability from a software perspective is just a key insight that 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 we're trying to bring to market.
No, I think it's an important one to hit, and I'm glad you mentioned it because I mean, there's so many solutions and software out there that's positioned as here's this new or different thing or adopt this, be able to create efficiencies, all of which may well be true, but that means this change in what a utility is doing, and there's a lot to that. So your starting place of integrating with what somebody is already doing, it feels like it just is going to lead to much more productive and easier conversations.
Yeah, absolutely.
Excellent. All right. Well, as we wrap up, we've been talking on electricity and power. So, I mean, Mike, tell me something powerful.
Well, look, as I said a few times, we are just seeing what's happened across other industries. And look, the importance of what needs to happen in the energy space is so huge. Getting it right is so important. So we absolutely need to be learning the lessons from other industries and applying them here. And we're seeing it happening. So it's a super important industry to work in, and I'm super excited to be doing it.
Excellent. Best way to learn more, stay in touch, imagine website and maybe LinkedIn or any socials that you guys are especially active on.
Yep, we're on sense.com and all the socials, but sense.com is a good starting point.
Excellent. Mike Phillips, appreciate you taking the time. We'll stay in touch.
Thanks so much.